So here we're looking at the graph of some function. Maybe it's the entire function, or it's a partial graph of the function on a specific interval. So here the interval would be the interval -2 and 3. Okay, so we're going to look at the behavior of that function on this interval. So on the interval -2, 3. Okay, what do we have here? Okay, we have some those points that I have here. There, some of them are kind of special. Let's look at this point here, -1, 3. So as you can see, -1, 3. If I slide from left to right along the curve, I'm gonna go up and then back down. So essentially at -1, 3, I've reached locally, okay, so in this neighborhood, the highest point of the curve. Okay, so it's as if you're taking a hike. You walk to the top of the mountain, so locally you're at the highest point in this area. So of course there's Mount Everest elsewhere on the earth, so there are points that are higher than where you are. But locally, this is the highest point. So we call that point a local maximum. Okay, so we'll say that there's a local maximum of 3 at x equals -1. So the y value is technically what the local max is. Although sometimes you could say that the point itself is the local max, or that x itself is the, but usually not. We wouldn't say that x itself is the local max. So either the point or but more in general, people will refer to the y coordinate as the local maximum. Okay, and can you spot a local minimum? Right there. There's a local min right there, right? If you go down, you're at the bottom of the valley at 2 - 2, so that's called a local min. So we're going to say that this is there's a local min of 2 or -2? Yes, the y coordinate. -2 at x equals 2. Okay, but now if we look at the entire graph of f on the interval -2, 3, what's the largest possible value of f on that interval? Now it's not going to be 3. 3 is locally the largest value of y in the neighborhood of -1. But if you look at the entire curve, it's 4, which is the highest value. So we're going to call this the absolute max. So absolute max of 4 at x equals 3. So on Earth, when you're on top of Mount Everest, you're at a local maximum, but also at the absolute maximum in terms of altitude on Earth. And then there's the absolute min. What's the absolute min of this function? Well, it turns out that this y value is both a local and an absolute min. Okay, absolute min of -2 at x equals 2. Okay, so I hope you understand, like, intuitively what local and absolute minimums or maximums are about. If not, you can read there are more precise definitions maybe in the book. But this is I think if you understand this example, you'll understand what those are. Now, we want to talk about also how this function here increases and decreases on different parts of the interval -2, 3. So we see here, for instance, okay, from between -2 and -1, that the function is increasing. It goes up. And it goes up when I go from left to, it's always moving from left to right. And this region here it's going to be decreasing. And after that, it increases again. Okay, so in particular, when you've got a local max, you increase and then you decrease after reaching that the local maximum. And for a local min, it's the opposite. You decrease and then you increase afterwards. And how is that connected with our average rate of change? So look at the interval minus 2, 3, where we are increasing. Let's take a look at maybe 2 points on this interval. So maybe let me erase a few things here so that the graph doesn't get too overloaded. I'm going to use a different color too, so blue. If I take 2 points, okay, on the curve, and that are where the x values are contained in the interval I'm looking at, okay, if in this interval, no matter which points I take, the average rate of change is positive. So if the slope is positive, that function is going to be increasing in that on that interval. So let's add the fact that here ARC is positive. Okay, it would be ARC on some interval AB that's contained in the interval minus 2, 3. Okay, so I could write ARC AB. Okay, so this is actually a way of defining that a function is increasing on an interval. And usually we define increasingness and decreasingness on an open interval. So we're going to say that on the open interval minus 2, 3. Okay, so this is interval, not a point. On the interval minus 2, 3, when you've got 2 points such that A is less than B and they're between 3 and minus 2, okay, then what you have is that the function value at B is higher than the function value at A. Okay, and when you have got this condition, okay, A less than B implies f of B is greater than an A, right? So A less than B implies that f of A is less than f of B, which means that f of B is higher. You've got a positive average rate of change, and that means that the function, if it's true for any A and B in the interval, it's going to be increasing on the entire interval. And we're going to say that an f is increasing, okay, on the interval minus 2, 3. Okay, note that the average rate of change is going to be, in this case, positive. Okay, so this relates increasingness to the average rate of change. Like if, as far as you're concerned, all you need to be able to do is look at a graph and say, oh, this is where it's increasing, this is where it's decreasing. But just know that it's related to the fact that average rate of change on that interval for any 2 points would always be positive. So similarly, if I look at the interval minus 1, 2, if I now take 2 points, okay, let's say one that's here and then another one that's there, you can see that f of A will be actually greater than f of B, and you're going to have, for any A and B on this interval, you're going to have a negative average rate of change. So when you have A is greater than 1, A is less than B, and B is less than 2, then in this case you're going to have that f of B is actually less than f of A, and f is going to be decreasing. Decreasing since as you move from left to right, the function values are going down. So decreasing on minus 1, 2. Okay, note that in this case the average rate of change is going to be negative. be negative. Okay, and I don't know if it's obvious, but the average rate of change, right? It's still f of b minus f of a or b minus a. So for instance, if it's negative here, at the bottom it's always positive. So the sign depends on what f of b minus f of a is. So if we're in the case where f of b is less than f of a, f of b minus f of a will be something that's negative. So that's why you'll have a negative over a positive will give you something that's negative, okay, less than 0. Okay, so let's remove this. And finally, okay, for similar reasons, on the interval 2, 3, functions increasing, you've got a positive average rate of change for any AB contained in that interval. So I'll just write here, okay, I won't write everything. F is increasing. Okay.